Hey guys, today we're bringing you our coil gun project. This is a continuation of my senior design in electrical engineering, and it's being expanded with the help of my good friend Nick.
Howdy, well let's get right to it. Let's go back to the workshop and we'll show you all the details.
Right here we have the main power switch, and right next to that we have the main power port, which in this case is a 12 volt DC connection, which powers the whole coil gun. Let's begin by turning on the main power. We can see that the systems are now initializing. In the top right corner here we have a voltmeter display which measures the voltage on the capacitor. Right next to that we have two leads which allows us to manually measure the voltage on the capacitor in the event the display fails. Below that we have a charging switch. Flip it all the way up and it begins charging the capacitor. Put it in neutral and it holds steady, and flipping it down will begin to discharge the capacitor. Right next to that we have a potentiometer which allows us to have a variable output voltage onto the DC-DC boost converter inside here, which has a range of about 120 to 205 volts approximately. Come to the left side of the control panel, we have the main fire switch. Flip it up, we would fire the projectile. If there was one in the coil gun, it would have fired now. Right here is an LCD display which measures the velocity of the projectile in meters per second, and then this is a reset switch to recalibrate and reset the chronograph. In the very top left we have a USB port which allows us to connect to the microcontroller inside, which is in this case an Arduino Uno, and in case we need to reprogram the chronograph. Inside on the breadboard there's a couple major components. Here's the DC-DC boost converter, which allows us to take the 12 volts and convert it from output between 105 and approximately 210. We have the discharge circuit here, which is a couple power resistors in parallel to discharge the capacitor. These resistors and wires here represent the chronograph and the measurements being taken to determine the velocity of the projectile. Obviously the elephant in the room is the capacitor, and it's 220 volts, or 200 volts and 18,000 microfarads. Over here we have an Arduino Uno, which is used to take the chronograph measurements. Here's the back side of the LCD display and the voltmeter over here. This is currently a 6-stage coil gun. Each stage is comprised of an IR sensor, a coil, an IGBT, and a diode. The coil allows us to produce electromagnetic force that pulls the ferromagnetic projectile down the barrel at high velocities. The IR sensor allows us to determine the projectile's position in the barrel, and in combination with the IGBT and the IR sensor, the two of them allow us to turn on and turn off the flow of current to the coil. In order to protect the IGBT from the reverse EMF produced by the coil when we quickly turn off the flow of current, we have a diode which allows us to dissipate that energy.
Let's get this thing ready to fire. Alright, here's the moment you've all been waiting for. The test fire. Scott, would you please load the projectile?
Alright, beginning projectile loading. Projectile has been loaded.
Alright, main power on.
Main power is enabled.
Initiate charging sequence.
Alright, charging the capacitor bank. Capacitor bank is almost fully charged. We're at 100. We're at 120. Ready to fire.
Enemy jellies are lined up and ready.
Alright.
Please initiate.
Firing switch open. Firing in 3, 2, 1. Fire!
Okay guys, so this is the coil winding machine. In building and testing the coil gun, we had to make a lot of different sizes of coils, a lot of different diameters of wire, so we made this machine to make that a little bit easier. So here's the mechanical side of things. It works a lot like a bobbin winder on a sewing machine. So the wire will start on a spool over here. It'll go onto this wheel here, which has a brake kind of tensioner built in. Go onto this final guide roller and onto this spool. So you have this spool rotating, winding the coil, and this carriage with the tensioning wheel and guide wheel on it are moved, I guess, parallel to the axis of the coil by this Acme thread on these linear motion guide rails. That's all done with the stepper motors 1 and 2, controlled by a couple Arduinos and some motor controller boards. I'll turn you over to Scott.
Here we have the user interface and control panel for the coil winding device. We're going to begin by powering it up. You can see it's initializing. We have two options, calibrate and wind. And we have a keypad which allows us to choose between the options. We're going to begin by calibrating the device. You can see that it's beginning to zero in on its position. Now that the device is zeroed in, we are going to go to the wind option. For this demonstration, we're going to choose a 24 gauge wire, and we're going to select 5 layers. Nick, I'll let you talk about the winding of it now.
Sure. So as it's winding, you see the carriage is moving parallel to the axis of the coil and is guiding the wire along the coil. The other motor is just spinning the coil, winding up the wire. Pretty simple process. Once it reaches the end of the coil, the carriage will reverse direction and start winding the wire the opposite